should have heard the way you just said
All right,
it.
we gotta finish up 4.3. We've been in 4.3 for forever. So let's finish that up today. So according to my notes, I'm gonna check with Jillian. Am I on 7B?
Yeah.
Okay, so here we go. We're on problem 7B on page 44. Speaking of donating things, next week is also a blood drive, so if you are able.
Oh, basically.
Alright, sine theta equals root 3/2. Alright, now I'm gonna answer the question in degrees and radians both. So here I go. First of all, I have to figure out all of the angles that have a sine of root 3/2. Now, let's think about where those angles could be. Remember your butterfly bow tie? Which triangles of the 4 options we have, which would have an opposite of root 3 and a hypotenuse of 2? Where could that happen? That could happen here for sure, couldn't it? Couldn't it also happen over here? Now, it can't happen down here because down here, opposite would be negative. So these are our 2 options. The minute you see that, you should think 60. Because you know that across from a 60, if that's root 3 and that's 2, that's 1. That's a special triangle. And across from the root 3 is 60. These 2 triangles are identical to each other in terms of size. So if that's a 60, that's automatically going to be a 60. So, my first angle is right here. Remember, you start measuring here. So your first angle is 60 degrees. Now your second angle, remember, you start measuring here. So your second angle comes over to here. What would that angle be?
150.
Not 150. Remember, this is 180.
120.
Wouldn't that be 120? Guys, if that's 180 and that's 60, then won't that be 120? So those are the degree measures. Now we're going to change them into radians. Now you can do that with your proportion, or hopefully some of us are going to be able to do that kind of logically. What is 60 degrees? Isn't that a third of pi?
Yeah.
So this would be pi over 3?
Yeah.
180 divided by 3? And then isn't 120 just 2 times that?
2
So 2 pi over 3. Now again, I hope we all get to that point where we don't have to say pi over 180 equals something over 60, but that will work every time. Every time. You can change degrees into radians that way. All right, Ronan?
Where'd you get the 3 for the denominator?
You divide 180 by 3.
180 divided by 3. 1/3 of 180.
And it's the same for 120 as well.
60 times 2 is 120, so I just took 2 times that. All right, let's try this one. Tan equals 1. Now I'm going to think of that as 1 over 1. So again, if you're starting to get your pieces put together, tangent is opposite over adjacent. And if they're both 1, if opposite and adjacent are both 1, don't we have a 45-degree triangle? Isn't that where you have 1/1? All right, maybe not. I mean, yeah, let's figure it
Obviously,
out.
yes.
So,
Of course.
I heard somebody say we're here, because that would be 1/1. Where else could we be though, you guys?
The bottom left?
No, left.
Oh, bottom left, it's negative,
Well, let's
negative.
call that quadrant
Negative.
3. And yes, we're in quadrant 3, because what happens down here?
Negative or negative?
Won't that make a tangent that's positive 1?
Yeah, we'll actually do that. It's crazy. It's like it.
Now, the minute we did that, then I knew that angle had to be 45, right? That's what I was talking about before, which means this one's 45. So the answers to the problem are that angle, which is 45, and this angle, hang on to that, you're right. What is the greenish
225.
angle going to be? What?
225.
225. And how did he know that was 225? Because to here is 180, and then we went 45 more. Remember, this is 180. We went 45 more.
You're always going that direction. You're always going down.
If it's positive, yeah. For these problems, we'll always be going positive, yeah. Now, I need to change those into radians. So you can set up a proportion like this. That will always work. Or you can think about, wait, 45 is pi divided by 4? Pi over 4? A fourth of pi? So this angle is pi over 4.
5 pi over 4.
And this one is 5 pi over 4, because 225 is 5 times 45?
Yeah.
5 45s? But again, do not sit there and look at me with that glazed look. If you're not getting what we're saying, you're gonna set this up. And you're gonna put a 45 here, and do that one, and then you're gonna put a 225 here and do that one. And you will get exactly the same answers. What I want you to know is, you don't have to do all that work if it makes sense to you otherwise. All right, one more. Sine equals 1. Okay. I'm gonna think of that as 1/1. So I guess my gut feeling is always positive numbers, I think this, right?
Yeah.
Okay, does that triangle bother anyone?
No. I mean, yeah, because there's no special triangle.
Well, guys, can the hypotenuse be the same length as one of the sides? Is that possible? The hypotenuse is always the longest, always, in a right triangle. Wait a second, so that triangle's not possible.
It's a circle.
It's a circle.
Oh.
It's a circle. If the triangle's not possible, we look at our circle. Now, I'm gonna draw the unit circle, I'm gonna let the radius be 1. So what are these points? Let's look at all these points. If the radius is 1, then what would be these coordinates right here?
1, 0.
1, 0. And these would be 0, 1. And these would be
Negative 1, 0.
negative 1, 0. And these would be
0, negative 1.
0, negative 1. Beautiful. Now, if I'm on the circle, I'm not doing opposite over hypotenuse.
Do an X.
I'm doing
Y over R.
y over r. So I need to look around the circle and find a place where y over r is 1 over 1. Now remember, my radius is always 1. So that part's covered. So where is y 1?
Up, on the upper
On
half.
the top, which is what angle?
90.
90. So theta is 90 degrees. Is there any other place where y is 1?
Yes.
No.
No.
I don't think so. That's a negative 1, that doesn't count. I need a 1, a positive 1.
No.
So there's only one answer, 90, which is what fraction of pi?
Pi over 2.
Pi over 2. Half a pi, pi over 2. So yesterday and today both, if the triangle isn't possible, then you gotta go to your circle, right? That's how we do it. Go to your circle. Finally,
Damn, man.
finally, 4.3 done.
That was a long unit.
That is a long section. So 4.3 is done, and we will do, or have our homework due on Tuesday? Okay, 4.3 is gonna be due on Tuesday. All right. At some point, we'll do a little review too, and I gotta get your quizzes turned back as soon as we get everybody taking it. Because we've covered a lot. We've packed a lot in. But let's start today with something that's pretty easy. Let's start graphing. Okay, let's start sketching. So we're gonna go back to our BFFs. And we're going to graph y equals sine x. Now that was one of your BFFs, if you remember. Do you remember what it looked like?
Yeah.
It looked like this, right? Up, down, like this. Do you remember anything else about it?
Had like a range of -1 to 1.
Depends.
Exactly, up and down. So let's start with that. Good job, Jake. So 1 to -1. Okay, this one has no asymptotes. Ronan?
Did it cross the origin?
The origin. So it's hills and valleys, right? And it keeps going, hills and valleys, but you only need to draw one hill and valley. That is called a period. A period is the piece of the graph that shows the whole thing. So the sine curve is a hill and a valley, and then another hill and valley, and another hill and valley. So one hill and one valley is enough. You don't need to draw more than that. It starts at the origin, goes up, comes out. That's what a sine looks like. Now, you need to label the high point, so the peak of the hill, where it crosses the bottom of the valley, and where it ends. Super simple. There are essentially 4 chunks. The 4 chunks are the 4 quadrants. So the first chunk goes from 0 to 90. So this should be 90, except it says use radians. So instead of 90, what am I gonna say? Pi over 2. And then the next chunk goes to 180, but I'm not gonna say 180, I'm going to say pi. And then the next chunk goes to 270.
Pi, 3 pi over 2.
3 pi over 2, 1.5 pi's. And the last chunk, 2 pi. So these are half pi sections. 90, 90, 90, 90, half pi, half pi, half pi, half pi. The period of the sine is 2 pi, all the way around. If I graphed a another hill and valley, it would end at 4 pi, 2 more pi's. And then the next one would end at 6 pi and so on, wasted time, don't do all that. 1 period is enough. The height of the curve is called its amplitude. So the amplitude of a sine function is 1. Goes up 1, goes down 1. Alright, that's easy enough. Can you translate that into a cosine curve?
This one goes through the minus, right?
Well, yeah, first of all, everything is exactly the same in terms of labeling. Everything is exactly the same. But what's the difference?
This one goes through the wires.
It starts here and ends there. This one looks like this. Now, that looks very strange, but remember, it goes on forever and ever in both directions. So if I do that, if I just kind of sketch in, do you see the hills and valleys? The issue is, when we consider it, we're only supposed to look at the part from 0 to 2 pi. So we kind of cut the hill in 2 pieces. Here's the back half of the hill, there's your valley, and there's the front half of the hill. So, again, period's 2 pi, and amplitude is 1. The sine and the cosine are exactly the same curve, just shifted.
We don't have to draw like pi over 2, stuff like that, do we? We just like draw pi and 2 pi.
No, you have to draw them all. Because these are important points, because those are the x-intercepts.
Oh.
Those are the zeros. So, yeah. So when you label, you gotta have, good point, I'm glad you asked that, Dina. You gotta have 4 things labeled on your x-axis, and then your top and bottom over here on the y-axis. I believe on your green sheet, I put those on the back, so you can reference those if you get stuck. All right. Let's look at the next question, which is 2 sine.
So the amplitude increases.
The amplitude increases. Very good. So we're going to draw the sine curve that I just erased. We're going to draw that exact picture, except instead of going up 1, he's going to go up 2. This number multiplies your amplitude. So the normal amplitude is 1. This amplitude is going to be 2. Nothing else is going to change. So we have our normal labels. It's a sine starting at the origin. Okay, now it looks like this. How many of you have ever heard the word amplifier?
Never heard it?
Have heard it,
Oh,
okay? When you,
yeah.
what does the amplifier do?
Amplify something.
Yeah, what's that?
Makes it louder, makes
Makes
it
it,
more,
makes
more.
these taller, which makes them louder. When you change the amplitude, you're changing the height of your waves,
Yep.
turning the volume up and down.
Yes.
So, amplitude 2, period 2 pi for this guy.
Now, what changes it side to side? What stretches it out?
Ooh, I don't know. D, negative 3 cosine. Any thoughts on this?
Smaller.
Good thoughts all around. What if that weren't there?
It would just go up.
So
But
my
if it's negative, it goes-
amplitude would be 3. Would you agree with that?
Yeah.
What does putting a negative
Flip side,
in
flip
front
side.
of something
It
do?
flips it side to side.
Which way does it flip it?
Side to side.
Right to left.
Upside down.
Upside down.
Oh.
Upside down. A negative out in front flips you upside down. So what does that mean? That means, now where would a cosine normally start? Wouldn't he start here?
But now it's starting down.
Now he's gonna start down here. So you're gonna have an upside down cosine curve. Try to remember to put arrows on each end because truly the curve does keep going. I sometimes forget, like here, but try to remember to do that. Notice my horizontal labels haven't changed because a number out in front changes the amplitude. That's what happens. There's no other numbers in the problem, so the only number I have is in front, it's gonna change the amplitude. The amplitude of this is 3, and the period is still too high. Amplitude is positive because amplitude is height. So isn't the height of the scale still 3?
Yeah.
It just happens to be upside down.
Would you count it off on a test if you didn't put arrows in?
No, because I forget half the time, but try to remember.
Okay, I'll try. For what? What you said?
Jake, where's your head down?
You said if you forget to put arrows.
Oh no. Are you gonna be okay?
I have no idea.
You know what I find helps?
What?
Focusing on my sine curves, that really helps me.
I have taken
Yeah.
notes.
It's his,
All right.
it's his cycle. Like he's going through his whole cycle. He has like his own little cycle right now. Little, like,
Dirty, that was a good one.
You guys never listen to the radio, but we have an old-fashioned radios, you know, like my car. You have AM stations and you have FM stations. AM stands for amplitude modulation, amplitude modulation. So if stations are broadcasting on a frequency where they are changing the amplitudes of the curve, that's an AM station, okay? FM stands for frequency modulation, and frequency is associated with this direction. So, we are now going to look at a problem
This is higher and wider.
that looks like this. Now, there are 2 things happening in this problem.
Higher and wider.
This guy right here multiplies my amplitude. My normal amplitude is 1. So this amplitude is going to be 2.
Should you turn it up? It goes by 2.
It's gonna stretch by 2.
Just hang on. You learned way back in section 1.6 of your textbook that when you put a coefficient on x, it actually divides the
X.
period, divides the width.
So it
It becomes more narrow.
It divides.
Divides.
oh, so it shrinks it.
Yes,
It
so
shrinks it.
this number is a multiplier. This number is a divider. All right, so this is where your eraser might come in handy.
Okay.
What are the normal labels?
Pi over
Pi
half.
over 2, pi, 3 pi over 2,
It has to
and
be
2 pi.
pi over 4.
Right? Now, they're all gonna get divided by 2, which is the same as timesing by a half. Right? The whole thing is getting divided by 2. Well, these are fractions. So instead of dividing by 2, I'm gonna multiply by a half. Okay? So this won't be pi over 2 anymore. This will be pi over 4. And this one will be pi over 2.
So your period is to
3 pi over 4. And plain old. So my amplitude is 2 and my period is just pi. It's half of what it was because this divides the period. So instead of being 2 pi, now it's pi. All right, Ronan?
There was no X next to it. Would it be like would it stretch it? No.
There'll always be an X
Oh,
there.
okay.
You need Y's and X's to graph it, so there'll always be an X there. Okay, this is a sine curve, so I start at the origin. And there we go, my friends. Shape is not gonna change, ever. Could be taller, could be fatter, skinnier, whatever, but it's gonna be a hill and a valley. That's what sines look like.
Over heavens.
I know.
That's a lot.
This is, oh, look at the next one, look at G.
So is that a
Let's focus on F first.
Is that a coordinate?
Okay, so let's just talk about what's happening in this picture. First of all, can you tell me, before I draft it, can you tell me what my amplitude's gonna be? Right, my amplitude's gonna be 3. Now, how do I know that? Because the normal amplitude is 1. That number multiplies the amplitude. What's my period?
2.
Okay, what is the normal period of a sine curve? 2 pi. What does that number do? Nuh-uh. What's that number do?
Pi.
Divide. So the normal period is 2 pi, but I've divided by 2, so now my period is pi. So that means start to finish is going to be pi. But here comes the tricky part. What does that do? What does adding or subtracting?
It adds plus 4. Pi plus 4.
It moves you
To the right,
left
to the right.
and right. Now remember, if the number is on the end of the problem, so let's say a plus 8 out there, that lifts you up and down, right? If the number is inside the parentheses with the x, it moves you left and right. And it's opposite of what you might think. So that's x minus pi over 4. It's actually moving to the right. So this curve is not going to start at the origin. It's a sine. It should start at the origin. But it's not going to because we have shifted everything to the right. So now I'm going to have a sine curve that looks like this. Now before I go any further, let's pause there. Dana?
Why don't we use pi? Why can't we just use like degrees?
Well, the directions say label in radians.
Oh.
And you remember what I told you at the very beginning of all this? I said pre-cal is like the transition time. So we're moving, we're getting ready to go to calculus, and there are no degrees in calculus.
Oh.
Everything will be radians. So we have to develop a comfort system with it. If you absolutely can't do it in radians, you could do it in degrees, but then you have to change everything back into radians, and that's a lot of extra
Yeah.
work.
I was wondering.
Okay,
Dude.
everybody's good to this point? All right, here we go. Listen carefully. We have decided the period is pi. That means from here to here is pi, 1 pi. This is not pi, because I started at a fourth. So if I start at a fourth, and I travel 1 whole pi, where do I end up?
Pi over 6. That's pretty obvious.
That's 1 and a fourth. If you start at a fourth, and you add on 1, where do you end up? You start at a fourth, and add on 1,
5/4.
you end up at 1 and a fourth. This is where I'm starting, this is 1/4, think of it as 1/4. And add 1, because that's our period. So I'm at 1 and a fourth, which is 5/4. A while ago, we had a problem that used these two numbers. This is 45 degrees and this is 225 degrees. Look, if I take 45 and add 180, which is pi, you know when I get 225? Okay, so now, this point right here is smack dab in the middle of 1/4 and 5/4. What's in the middle of 1 and 5? 3. So this is 3/4. This point is right in the middle of 1 and 3.
2.
So it's 2/4. I am not gonna count wrong if you don't reduce in your graphs. Obviously, that's pi over 2. So if you wanna do that, that's great, but if you don't, I'm not gonna count it wrong. It's okay, 2/4. And then this guy is right in the middle of 3 and 5. So it's 4/4, which is just plain old pi. Ooh, that's a lot. The good news is, most of it's just plain logic. Alrighty, here we go. This looks bad. Let's start by finding our period and amplitude. Amplitude's 1/5. This number right here, guys, multiplies the amplitude. Since the standard amplitude is 1, 1/5 times 1 is 1/5. So when I draw my picture, technically it's gonna be really, really small. I'm gonna make it a little bigger, but this is 1/5 and negative 1/5, okay? How about my period? What is the regular period of a sine or cosine?
2 pi.
2 pi. But what does this number do?
Pi by 2.
Divides.
By 1/2.
What's 2 pi divided by half?
4 pi. 4 pi.
4 pi. So from beginning to end, this is gonna be 4 pi long. Okay? Alright, speaking of beginning, where is this one gonna begin?
That would make negative.
Negative pi over 8. Remember, if you are adding and subtracting in your problem, you are moving your picture. Moving it. If you are adding and subtracting to x, you're moving it sideways. If you're adding and subtracting out here, that would be up and down. I have a cosine curve. Starts up here, because that's where cosines start. And the distance, I like to just draw my curve first. The distance from beginning to end is 4 pi.
Wow.
If I started at 0, this would be 4 pi. But I started at negative pi over 8. So to find this point, aren't I going to take negative pi over 8 and add 4 pi?
Yeah.
Where'd you get 4 pi?
That's on the.
That's the.
Oh.
Period
Oh, yeah,
is
the
2
period.
pi divided by that coefficient. Well, this is the same as negative pi over 8 plus 32 eighths. If you want to drop the pi's when you do the math, that's okay. Just remember to put them back in. Negative 1/8 and 32 eighths would be 31 eighths. So this label right here is 31 pi over 8. That's where it ends. It ends 32 eighths after it starts. Now, right here in the middle, the bottom of the picture, that guy right there is the middle of negative 1 and positive 31.
15.5.
Another way of thinking about that is midpoint or average. What's the average of negative 1 and 31?
15.
15. So this is 15 pi over 8. How do we find average? We simply add and divide by 2. So now this guy is the middle of negative 1 and 15. What's that?
7.5.
No, negative 1 plus 15 is
14, it's
7.
14. So this would be 7 pi over 8.
14. I know.
And then we've got 15 and 31.
46. 28. Psych.
18.
23.
Psych.
23 pi over 8.
23.
Thank you.
Dude, I
Goodness
couldn't
gracious.
2 6 on
Pi
that 2 was.
over 8. Now,
You're like, oh my god.
there is a ton of arithmetic here. One thing that will always be true,
This is so long.
from negative 1 to 7 is 8. From 7 to 15 is 8. From 15 to 23 is 8. And from 23 to 31 is 8. So when you're done, just make sure that all of these have the same, interval. Because everything's evenly spaced. Remember, it came off the coordinate system. These are quadrants.
Yeah.
All of them are equal. Don't yawn, oh my lord. Okay, so let's struggle
It's just a
through.
lot.
It is a lot. It is, there's no question about it.
Yeah.
So let's struggle through one more. All right, so everybody's paying attention, keeping your eyes open, writing it down. What is it? Y equals negative 2 sine 1/3 x minus pi over 7. So let's start with period and amplitude. What's my period going to be?
Negative 2.
No,
2. It's 2.
It's pi over.
It's 2.
2 pi over
Oh my
1/3. Period is 2 pi divided by that number.
Amplitude is 2.
So what's 2 pi divided by a third?
6 pi.
6 pi. So that means start to finish is 6 pi. Now what's my amplitude?
2.
2. And that tells me that when I get around to drawing it, it's gonna be
Start from bottom.
upside down. Okay. Now, what does that tell me?
It's starting from right.
It's
Pi over
starting at pi over 7. I have an upside down sine curve that starts at pi over 7. Now remember, sines normally start at the origin.
Mhm.
So this just gets shifted over to here. So it starts there. There's my valley. There's my hill. And whatever that is, right there, that ending point,
That's what 6 pi go.
I know it's pi over 7 plus 6 pi.
So 43.
So it's 1/7, I'll leave the pi's out for now. It's 1/7 plus 6,
43 pi.
which is 1/7 plus 42/7.
Yeah.
So it's 43 pi over 7.
Question.
Mhm.
Can the period ever be negative?
No, period and amplitude are positive.
So it can never be always like in the middle.
You can, but the period would still be the period. The period is going to be a positive number. You would just be backing up 6 pi instead of going forward 6 pi. So these labels would be negative. These numbers would be negative, but the period itself is still positive.
Okay.
Okay. Now, this guy right here is exactly in the middle of 1 and 43. Would you agree with that?
22, 21, 22, 22. 22 pi over 7.
22 pi over 7, good. Remember, all of these things are in the middle, so you're just averaging. You're just averaging. So now I've got 1 and 22. I have to be in the middle of 1 and 22. Okay, we don't put decimals in there, so here's how we handle it. When you add these together, you get 23, right? Sevenths. Would you agree with that?
Yeah.
When you cut that in half, you actually get 23 over 14.
Oh,
So one more time.
14.
When we're finding the midpoint or the average, we add and divide by 2. Well, when you add these, you get an odd number. So if you tried to divide by 2, you'd have a decimal in your fraction, and we don't want that. So instead, we'll take that 23/7 that we get when we add and cut it in half and make it 23/14. We're gonna do the same thing here, because 22 and 43 make 65. So that's 65/7. So half of it would be 65/14. Oh my gosh,
So
that's a lot.
that's a lot. All right, I'll pause there. Woo.
my head hurts.
Because we're gonna have prayer here in a minute.
That was a big one. Today was a big one.